Hello students, today we are going to start the multiple choice question series from new subject, that is linear algebra. The first question is, which one of the following is not a vector space? R over R, C over C, R over C and C over R. R over C is not a vector space because multiplication of a real number with a complex number is not necessarily be a real number. That's why this is not a vector space. So correct answer is a RC. Next question is, let V be a vector space where AB belongs to F and alpha and beta is in V. Then which one of the following result is incorrect? First, for vector space we can easily prove it out that A into alpha minus beta equals to A alpha minus A beta. This is right. A plus B into alpha equals to A alpha plus B alpha, and A into minus alpha equals to minus A alpha equals to minus A into alpha. That means we are left with this option third. So this option number third is incorrect one. Next, let S be the set of all ordered pair of real number. Define addition of pairs as follow: x1 comma y1 plus x2 comma y2 equals to x1 plus x2 comma y1 plus y2. Then S be a vector space if multiplication by scalar is defined as. From this definition we can easily verify that Cxy equals to Cx comma Cy. That's why option number 4 is correct one. Next question is, the number of elements in the vector space of polynomial of nth degree, in which coefficients are elements of the field Zp, where P being a prime number. We have already solved this question in our previous video. I am just putting down the link over here. You can check it out. But let's try to solve this. If we have a field Zp, then this field will have P number of testing elements. Okay. And the polynomial of degree at most n over the field Zp will be written as fx equals to a0 plus a1x plus a2x square up to plus an x to the power n. That means we have n plus 1 terms in this polynomial. Okay, we have P number of distinct elements in this field Zp and n plus 1 terms in this n power polynomial. That's why the correct answer will be P to the power n plus 1, because as we know that a simple term, this a1x, a0, a1x, a0, a1x, a2x square and anx square can be filled in p different ways. That's why the final answer will be p to the power n plus 1. Next question is, a subspace of a vector space V over a field F other than V is called? It is called a proper subspace of V. Zero subspace is nothing but a subset 0 consisting the 0 vector alone in the subspace V is called a 0 or null space. And every vector space V over a field F has two trivial or improper subspace, that is a 0 subspace and a subspace V itself. Okay, that's why our correct answer will be proper subspace. Next question is, the necessary and sufficient condition for a non-empty subset W of a vector space Vf to be a vector space of Vf is that if AB is in F and alpha beta is in W, the condition will be A alpha plus B beta should belongs to W. That's why the condition is fourth one. Next question is, if W1 and W2 be two subspaces of a vector space V over a field F, then one of the following will always be a subspace of V. In this case, the intersection of two subspaces will always be a subspace of V. That's why the correct answer is W1 intersection W2 will always belongs to this VF. Okay, union of two subspaces may not be a subspace of VF, because union of two subspaces is a subspace if and only if one is contained in the other. That's why the condition will be W1 intersection W2. This will always be a subspace of V. Next question is, vector M31 is a linear combination of E1 and E2, then the value of M is. Let's try to calculate the value of M1. Let M31 equals to AE1 plus BE2. Okay, then this M31 will be equals to A. We are putting out the points here. Then this will become 3A comma 2B comma A plus 2B comma B and then 0, and then when we further solve it out, it can be written as 3A plus 2B comma 2A plus B comma A. Okay, which implies this first term will be equals to M, this 2A plus B will be equivalent to 3, and this A will be equivalent to 1. When we solve this one, we will have B equals to 3 minus 2A, that is 3 minus 2, that is 1. That's why M equals to 3A plus 2B, and hence the M equals to 5. So the correct answer will be, next question is, this is similar to previous question. E equals to E1, E2 and E3 are given. These are three vectors, and the vector belongs to R3 is a linear combination will be. We have to find out the linear combination. So what we have to do is, we have to write this 3 comma 5 comma 2 as A E1 plus B E2 plus C E3. Okay, and then we have to find out the value of A, B and C, and then replace in the linear combination, and we will have the results. Let's try to solve it out. Let 3, 5, 2 equals to this one, and then this is a simple process. We have this 3A plus 2B plus C will be equals to 3, 2A plus B will be 5 and A will be 2. When we solve these three equations, we will have A equals to 2 and B equals to 1 and C equals to minus 5. That's why the linear combination will be 2E1 plus B यानी कि 1 यानी E2 minus 5 E3. That's why the correct answer is option number 2. Next question is, 2, 4, 16 belongs to R3, can be expressed as a linear combination of alpha, beta and gamma. And this is similar to the previous question. What we have to do is, we have to express this 2, 4, 16 as a linear combination of A alpha plus B beta plus C gamma, and then we have to find out the value of A, B and C, and then we can easily find out the linear combination. And we have 2, 4, 16. It will come out as A minus 2B plus 5C. Second term will be 3A minus 7B plus 14C, and the third term will be 5A minus 9B plus 26C. This simply implies this first term will be equal to 2. This 3A minus 7B equals to 4, and this 5A minus 9B plus 26C will be equals to 16. When we solve these three equations, we have A equals to 3, B equals to 3 and C equals to 1. But when we put these value back into the equation 2, this equation does not satisfy. Means when we put A equals to 3, B equals to 3 and c equals to 1 in this second equation, the right hand side is not equals to 4. That simply means this linear vector has no solution.